All right, we're continuing with section 1.4, completing the square when leading coefficient is not 1. So we did it with 1 as the leading coefficient, and it was easier.
Why did we learn this after the homework was due?
So here's completing the square, leading coefficient is not 1. So if I say solve 2 squared plus 8x
Mr.
plus
Shadle,
3, yeah.
I saw you move 1.4 to next Wednesday for deadline. Is that right? Because I spoke
Oh
to
my
you.
god.
Because I spoke to you last time during math class.
Mm,
So you moved it or you didn't move it?
I don't know. What's it say on Blackboard?
I think it's still due July.
It's still today.
Yeah, it's probably due today,
It's not like I can really do
but you don't need it. I mean, it's not that hard. It's not that hard. All right. What was my rule for like if I were to write on my note card my rule for completing the square? What's completing the square look like as a rule? Like just as a general form?
Ax squared plus bx plus c.
Not right. That's not correct. X squared plus bx plus c is what?
Generic.
This is the standard form
Yeah.
for a what?
Quadratic equation.
Yeah, quadratic. So it would need to be x squared plus bx plus c equals 0.
What makes this a quadratic?
It doesn't have it has 1 as the
No.
thingy on that as well.
This is general. A could be anything except 0. B could be anything at all. C could be anything at all.
Question, what is C in the one you asked us to solve?
That's 3. That's 3.
Okay.
Yeah.
It's like
I was given the
What makes this a quadratic? Finn.
It follows the standard quadratic form.
What makes this a quadratic? Is this a quadratic?
No.
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 Nope.
Is
There's
this a quadratic?
No.
No.
There can't
Is
be a
this a
line.
quadratic?
There can only be
Wait.
one.
Wait.
What makes this a quadratic and what makes these not quadratics?
It has a square.
It has the highest power is
A square.
2. Yeah. Highest power is 2. So this is standard form. That's useful to know, but that's not my rule for completing the square. What's my rule for completing the square, Cormac?
I have it written out. To complete the square for x squared plus bx, add b divided by 2 squared, or half the coefficient of x.
Right. So what does that look like if I were to take up the tiniest possible space on my note card?
I would write x squared plus bx plus b over 2 squared equals x plus b over 2 squared.
Or 0 or something plus your 2 squared.
So say it again.
X squared plus bx plus b over 2 squared equals x plus b over 2 squared.
B over 2 squared like this, the whole thing squared,
Yeah.
equals,
X plus b over 2 squared.
right. So this is worth a tiny space on your index card, cheat sheet.
Oh, yo comprehendo now. I was thinking of
So this is and I would title it completing the square. Maybe write it above it.
Ooh.
So if I'm asked to solve something that looks like this, can I use this?
Yeah.
Ish? Not really.
No.
Can't use it directly. Why?
There's a
Yeah,
2 in front
yeah,
of the
when
x
you-
squared, not a 1.
Yeah, when you first factorize it.
Yeah,
But then you can divide it by 2, right?
I could divide it by 2. So in the context of a larger problem, I sort of do have the option of factoring out 2. What would that leave?
X squared plus 4x plus 1.5.
Plus 3 halves. So that's one option. I could factor it out if I needed to carry it forward for some reason, like if I didn't have 0 on the other side, for example. But I do have 0, so I can just divide both sides by. That is a valid option, but I could divide the whole thing by 2, both sides by 2,
So that's
which gives me which gives me
X squared plus 4x plus 1.5 is equivalent to
3 halves.
0.
I'm leaving it in an exact form, even though 1.5 technically is exact. If I leave it in fraction form, it's easier to work with, in my opinion. Equals what on this side? 0, right? So can I use my completing the square?
No.
No.
Minus the 3 halves of both sides.
Okay. Now can I use it?
Yeah. So.
Yeah, so all I have left here is x squared plus bx. Now to do my completing the square, off to the side I'm going to write b. I want to write b over 2 because I'm going to end up needing b over 2, and I'm going to write b over 2 squared because I'm going to need that here as well. So what's b?
4.
What's b over 2?
2.
What's b over 2 squared?
4.
4. So over here, what do I write, Patrick?
That would be x squared plus 4x plus 4.
Plus 4. It's this 4 over here, right? Equals.
Oh.
What's on the right side of the equation?
Negative 3 over 2.
Negative 3 over 2
Plus 4.
plus 4.
Squared.
No.
No,
Where does this come from?
from the squared.
No.
No, that's like because.
Because you add it on one side, it has to
If
be.
I add it on one side, I have to add it on the other to keep it equal.
And then you can use.
So this part is the magic of completing the square. This right side is just accumulating junk. I brought this over here to get this by itself. I brought the 3 halves over to make this side match my completing the square pattern. And then I added 4, but I have to add 4 to both sides. So I'm just accumulating junk over here. I'm accumulating my remnant, sort of.
Yeah.
All right, so let's complete the square on the left side. What do I get, Cormac?
On the left side?
Yeah.
X plus b over 2 squared. So that's x plus 2 squared.
Right, this 2 here,
Yep.
squared equals.
It's 5 halves.
It's 3. It's negative 3 over 2 plus 8 over 2, 5 over 2. Okay, and now I can just proceed with what's this called? What's this way of solving a quadratic called?
I didn't write that down.
It sounds like you're going to the dentist.
Completing the square.
No, this was completing the square.
Oh,
This was-
extracting.
This was complete the square.
Extracting the square root.
Right.
We should play Hangman more likely.
And this is extracting the square root canal. Okay, no wait. Less dentistry related. Extracting the square root. So what do I do?
Use square root both sides.
Square root both sides. That gives me x plus 2 equals
Plus or minus square
plus
root
or
of 5.
minus
Or 5
square root of 5 over 2. Math teachers don't really like you to keep a square root in the denominator.
So
Can we do the
The,
fancy
The what?
fancy exponent thing?
What's the fancy exponent thing? What is, so just over to the side, what is root 5 over 2 equivalent to?
Root 5 over root 2.
It's equivalent to square root of 5 or square root of 2, and I don't want square roots in the denominator, so what do?
Multiply both by root 2.
Multiply top and bottom by square root of 2. Why can I do that?
Because root 2 over root 2 is equal to 1.
This is multiplying something that's equivalent to 1, and so the value doesn't change. Finn, I want you taking notes, not playing Tower of Hanoi.
I already did this part.
Okay, so what's on the numerator?
Two, just two. Oh, no, it would be like. Two.
What is square root of 5 times square root of 2?
Square root, it would be 10.
Right,
Over 2?
over 2.
Over 2.
Can I simplify square root of 10?
Yes!
No.
No!
What are the factors of 10?
5
2y,
over 2.
10, 2, 5.
Right. There's no squares here. Nothing that I can take out of the square root.
I was hallucinating.
So let's solve for x.
Yes, so x, it would be square root of 10 over 2 minus 2, and then the negative square root 10 over 2.
So I can just treat this as one thing. I can leave the plus or minus thing here. So I'm just going to take the negative. I'm going to take the 2 over. I'm going to subtract 2 from both sides. And that's my final answer.
X is equivalent.
Okay, you do this one.
Wait, I was still working through some stuff. How did the,
Well, I mean, going based off of what the other one was, it would be dividing the entire thing by 3. Divide everything by 3.
Right, why are we dividing by 3?
So that we have a coefficient of 1 on the first term.
Right, we want a coefficient of 1 on the first term so I can use my completing the square. And I'm going to write this down from my note card on my problem so I can use it. So I'm going to divide through by 3. This gives me what?
That's x squared minus 4/3 x minus 5/3.
Minus 5/3 equals 0, right? Next step. What am I trying to get this to look like?
Or you're trying to get it to look somewhat similar to the formula.
Right, so I have not added this part yet. I'm really just trying to get it to look like this part. I want it to look like this part equals whatever I have on the right side. I don't really care what I have on the right side. So what about this is not looking like this yet?
C.
Mm-hmm. So what do?
Addition property of equality. Add 5/3 to either side.
Yep. And then, Cormac, what do I do after that?
after the 5/3,
Mm-hmm.
the thing you mentioned, completing the square. Well, okay, so you're adding.
Not simplified though.
Can I put the 9 up here? With the,
No, that's not right. It's still not right. Let's do it together and you can see where you've gone wrong.
So what I did, was kind of a little out of the loop, but make sure.
No, there's only one thing for us to do right now.
Yeah.
In our-
complete
Right.
plus b over 2 squared on both sides.
So what do I write? So my technique is I'm going to write down my completing the square,
Yep.
and then what am I going to do, Patrick? So I need you to be following along with this because we're going step by step.
Yes,
If you follow-
writing it down.
If you follow step by step, I think you will not go astray. What's the next step here, Cormac?
Oh, it's 4 over 3 divided by 2.
No.
Oh,
My methodology is to write in my scratch paper over here and to
Oh.
decide. What am I going to write?
b over 2,
I'm gonna write,
b over 2,
no, my first step is not to write b over 2.
b equals 4 over 3.
Can you say it again? Because you were close, but not quite
b
right.
equals 4 over 3.
No.
Negative 4 over 3.
Oh, that's
Because
yeah,
it's
what I
x
did wrong
squared
last.
plus bx, and it's
Because it's x squared plus bx.
Mhm.
So my bx is this entire coefficient.
Yeah.
Yeah.
It's negative 4/3.
Yeah.
b over 2 is,
Negative 2/3.
right. b over 2 squared.
Was 4 over 9.
It's 4/9. Right. I'm going to space this out a little bit because it looks like I'm multiplying things when I'm not. So here's my b, here's my b over 2, here's my b over 2 squared. Right. So the next step in the procedure is to do what?
We can now start to complete the square right now. Yeah, like it would be x squared minus 4 over 3x plus 9 over 4 over 9 equals 5 over 3 plus 4 over 9.
Right. So the step that we're at right now is adding b over 2 squared to both sides. And you said it correctly, so I'm just going to write down what you said. What do I get on the right side?
It would be 19 over 9.
I don't care about the answer, I care about the methodology.
First you make the denominator to be the same, so 5 over 3, well, both multiply by 3, so it will become 15 over 9.
15/9 combines with 4/9.
Yeah, it would be 19 over 9.
And then what does that give us on the left side? What do we get for free on the left side?
So we can make it, so we can just add the parentheses and it will become x plus 2 over b squared, which is x plus
You say 2 over b?
oh, b over 2, b over 2.
b over 2?
So it will become x plus 4 over 9 parentheses squared.
No. So this is a potential pitfall. This is b over 2 squared. And this is x plus b over 2 inside the parentheses with the square outside the parentheses. So I don't need 4/9 here. This is this part, we're at this stage right now of bundling this up into a square. We made this into a square, and now we can bundle it up into something squared.
Okay.
So what is it on the left side?
So left side would become x plus it'll just become negative 2 over 3.
Yes, because this is my b over 2.
Yeah.
This is b over 2. This is b over 2.
And
This is b over 2 squared.
yeah. And the
This
right-
is b.
yeah.
So I need my b over 2 here. And
the
that
right-
here's where I used my b over 2 squared.
oh, okay. And the right side would be just 19 over 9. So the next step is to extracting the square root, which means
Let's do extracting the square root. What's extracting the square root do?
we just add a square root to both sides.
We're just square rooting both sides.
Yeah. And it will become x minus 2 over 3 equals the final answer will be square root 19 over 9. That's the simplified answer.
That's not correct.
Oh, plus or minus.
Plus or minus. So this is a very common pitfall in algebra. Is to call square root of 9 is obviously 3, right?
The
No.
channels will be down to 6.
Plus or minus.
Plus or minus.
Plus or minus 3.
Plus or minus, because 3 times 3 is 9, but negative 3 times negative 3 is 9. Cormac, you should not be on your calculator.
Sorry.
Okay, this one, I prefer, you can simplify this in place, but I kind of prefer to take things out to the side and figure out what they're doing, and then I'll pop it back in. As long as I don't forget important things like plus minus or signs. So what is 19 over 9? That is not simplified.
Square root of 19 over square root of 9.
Yeah.
So square root of 19 over square root of 9 is
Square root of 19 over 3.
square root of 19 over 3, and I'm okay just calling it 3 because this plus or minus is going to do my work for me. Equals plus or minus square root of 19 over 3. I'm very consciously ignoring the plus or minus 3 in the denominator there because I don't really need it. It's fine if I don't have it. Okay, we are on the way to simplifying. What else do we need?
So basically just move minus 2 over 3 to the right side,
Mm-hmm.
and it will become positive 2 over 3 plus or minus square root of 19 over 3.
Okay, good job. Okay, so somebody remind me the standard form for a second degree polynomial.
ax squared plus bx plus c.
Equals.
0 if it's quadratic.
Can we try? So this is the standard form.
Yes.
So if you had ax squared plus bx plus c equals 3, I would say you need to subtract 3 from both sides, and then that becomes your new c. So standard form for quadratic does equal 0, because any constant terms are going to just come over here. Can we try to complete the square on the standard form?
Yeah.
Cormac, where would I start?
Minus C.
I would subtract c from both sides. And then what do I need to do?
Divide.
Factorization.
I'm not going to factor it.
Well,
I'm
divide
completing
by
the
eight.
square. Complete
Well,
the square.
if the a didn't equal 1, then like you
Yeah.
have to do stuff with it before you put over the c.
A is not guaranteed to equal 1.
So
A is A. A is anything other than 0.
Yes.
Actually, that still works because even if you divide all of it by A, you're still gonna be dividing C by A, no matter what. So it still does work.
So I'm not ready to complete the square yet on this because I don't have a coefficient of 1. What can I do to get a coefficient of 1?
Divide all by A.
Divide all by A. That gives me what, Cormac?
X squared plus bx equals negative c over a.
No.
It's
Oh.
B over AX.
Equals negative c over
BX over A.
Yeah.
I'm going to multiply both sides by 1 over A. That looks like a 9.
So it's bx over a.
Yeah. Equals minus c over A. Good. So, what do I do here? How do I complete the square?
B over a over 2 squared added.
I don't want the answer, I want the method.
It's complete
Um,
square.
What's my method?
Completing the square.
Yeah. What are my steps?
X squared plus bx.
What are my steps?
B equals b over a.
B equals b over a. Okay, so this is a different meaning of b, right? So if it makes you more comfortable, I can call this capital B.
Still B, whatever. And then B over 2.
No, math is case sensitive.
Yeah.
So and what else do I need? I need b. I need
2.
b over 2,
Yeah.
and I need what else?
B over 2 squared.
And I need b over 2 squared. So what's b over 2?
B over 2 equals.
Cormac, what's b over 2?
B over 2,
Yep.
B over A over 2.
B over 2A.
Yeah, so it's like b over 2 equals b times 1/2, right?
Yeah.
So laggy. This is laggy. Why is this laggy? In about 5 minutes, it's going to catch up with what I've written. Drives me insane. So b over 2 is what?
B over 2A.
Oops, then I need another equal sign. b over 2a, right? And then what is b over 2 squared?
B over 2A squared.
Yeah, so I'm just gonna make this easier on myself. I'm gonna say b over 2a squared.
Yeah.
Yeah,
So that's b squared over 4a squared.
I could do that. I'm not going to. So what do I do with that? Add it to both sides. Add it to both sides. So I'm gonna write
Wait.
x squared plus. I'm sort of done figuring all this stuff out. So I'm gonna lapse back to my lowercase b's if that's okay.
Wait.
What am I gonna add?
B
B over 2a.
b over 2a squared to both sides.
Yes. Yeah. How wondrous.
That's more complicated than the real number.
Yeah.
Well, yeah, because you can't simplify anything.
Yeah.
If you have.
I can simplify. I can simplify quite a bit.
Well, you can simplify stuff in the sense.
I can simplify this quite a bit. I've set this up so I can simplify this quite a bit. What is this? What's this left side simplified to?
X plus
B over A.
B over 2A, yeah.
B over 2A.
Over 2A.
Parentheses squared.
All parentheses.
Square is out of the parentheses.
Oh, number right there.
Yeah.
Equal on the right side?
Oh, that was weird.
It's laggy. I'm writing it here and then it takes 5 minutes to upload. I don't know why.
Lovely.
It's crazy.
Equivalent to negative C over A plus in parentheses B over 2A out of parentheses 2.
Yeah, can I combine these?
No, not really. Well,
I can't.
yes.
Yeah.
You-
So let's go ahead and multiply it out.
Yes. So
And I'm gonna write the positive one first and then I'm gonna write the negative one second, if that's okay. So so let's multiply out b over 2a squared.
b over 2a squared would when simplified out becomes b squared over 4a squared.
Mm-hmm.
And then it's that minus c over a,
Right?
which you can then move. Actually,
Yeah.
yeah.
I need a what to combine these?
Common denominator.
Common denominator. How do I
What?
How do I get a
Multiply
common
by 4a.
denominator?
Multiply by 4a. Multiply c over a by 4a.
So if I multiply top and bottom by 4a, why can I do that?
Because 4a over 4a equals 1.
4 over 4a is equivalent to 1, and I can multiply it by 1 and not change the value. So what do I get? I'm going to rewrite this part.
B squared over 4A squared minus C times, or 4AC. Wait, that
Whoa,
sounds similar.
wait a
That's
minute.
familiar. That is familiar.
Over.
Oh, I see where you're going. You're
I'm
proofing.
not familiar.
Over 4A
You're lost?
squared.
Are you lost?
No, I'm not lost, but I'm just a little bit
confused.
we're getting a common denominator. So we had CA, we had A as a denominator here. We have 4A squared as a denominator here.
So we can combine that together.
Yeah, so what's my denominator here?
4a squared.
4A squared. And so I can just write these together as one.
4AC.
Wait a minute.
It's
Gives me
fun.
what?
Oh my.
What does it give me?
B squared minus 4AC over 4A squared.
Oh.
The 4A
Right.
squared's
This
a lot.
can't be happening.
C. You missed the
X
C.
I'm getting
equals
flashbacks.
negative. Plus or minus.
You missed
4AC up here. Okay. 4AC, right.
One.
C all over 2 times. No.
I suddenly know why you're doing this.
No.
So what do I have?
Okay,
I don't like this.
yes, whatever that is. Yes, all that. It moved the hand over.
So how do I proceed?
By myself.
Okay,
I reverse
okay,
engineered
okay.
it.
Okay.
Like I was just doing
Okay.
Square root both of
Sit
them.
down. Right, what do we do here now?
Square root both
I
of
hate
them.
Square root of both sides. Why do you hate deriving something that you already knew?
Yeah,
But
it's
it's
just,
because it's
the
familiar. It's the,
Why do you
it's
hate
the
that?
quadratic equation.
Why do you hate it?
obviously it is.
Yeah,
Why
but
is that
like-
bad?
I'll know.
Sacra, bluff.
Yeah, should
Super suckra, super bleh.
Yeah,
Wait, did you just
we should
say-
just listen to the quadratic equations on like 30
Yeah.
times after
Yeah,
this.
30 times. Yes, you should play it.
Yeah, you should force everyone to memorize it.
Should.
Yes.
You should. It would be fun.
And then make us write like.
What
100
do I
times on the
do
chalkboard.
next?
You square root both sides.
Square root both sides.
Square. Wasn't that so fun?
Square root both sides. That gives me x plus b over 2a equals
This is plus or minus square root.
plus or minus square root
minus
of b squared minus 4ac
4A
all over 4a squared.
You-
And then let me take this out to the woodshed.
Oh.
What is 4a squared in the denominator?
That is the square root of 4A squared.
It's all the quadratic formula. No.
It's always been the quadratic.
What's this?
The square
2A.
root of 4A squared.
Square root of 4a squared, which is
2A. Oh my god.
Standard form.
Oh my god.
equals plus or minus square root of b squared minus 4ac over 2a. All right, so now what?
Okay, and then we minus b over 2a because they both have the 2a.
Wait.
We kind of just put it all.
So I have
Wait,
x
I just
over here. I'm
realized.
trying to solve for x.
Yep.
Wait, I
That
just
gives me
realized.
x equals what?
X equals
Negative b over 2a plus or minus what, Finn?
I've always wondered how they got the quadratic formula, but now I just realized they were just like, hey, what if we just took standard form and just like, simplified it, and then they got the quadratic.
Almost there. Almost there.
And then you kind of smoosh them together because they both
Okay,
have the
okay,
same
and then
denominator.
they're gonna smoosh.
Yes, plus or minus the square root of
B squared minus 4 times c, a times c, all over 2 times a.
2a.
B.
Can we play the quadratic formula?
Make us write the quadratic formula 100 times on the
I think you
chalkboard.
just wrote the quadratic formula.
Yes.
All right, let's use the quadratic formula.
No, let's write it 100 times.
Let's sing it. This is choir class now.
X equals negative b.
I don't know. I forgot the.
I remember. I memorized a different song as a different rhythm.
I've never memorized this ever in my life.
B over 2.
I was never given the song.
X equals
My
negative b
math
plus or
career
minus
was
square root
depressing.
b squared minus 4 times a times c all over 2 times a.
Okay.
Mr. Shadle, you forgot to write a c in the quadratic formula.
Thank you.
Yes. Bx.
I really liked the other method, it was so fun.
Which method?
The long method.
Wait, 0 is equal to the quadratic formula. So whenever you see the number 0, you can just add the quadratic formula.
How do I solve this? Did you solve this?
Not yet.
That's pretty interesting.
I feel.
I just use the quadratic
You could just do the B over 2 thing, but you can also use the right form. I'm just writing.
What's
down.
my first step?
Are are you wanting us to? Oh yeah.
Yeah.
Put it into the quadratic formula.
No, that's not. I'm not ready to put it in the quadratic
Put it
formula.
into standard form.
Put it in standard.
So minus the
Form.
9.
Yeah.
Yeah.
So x squared plus 3x minus 9 equals 0. Now I'm ready to say what my a is, what my b is, what my c is. What's a, b, and c?
A is 1, B is 3, C is -9.
-9. And at this point this point I should write out my quadratic formula. Plus or minus square root. B squared minus 4ac. All over 2a.
What is 2a? Oh, 2a is, 2 is just 2.
So wait, I have a question.
Yeah.
Yes.
Oh, A and this is 1, okay.
So
Makes sense.
what's negative b?
It's
That's
-3.
-3 plus or minus. What's b squared?
9.
9. What's minus 4ac?
12.
That's,
Minus 12.
that's plus 36. Or am I going insane?
What's 4 times a is 1 times c is minus 9?
-9 times 4 is
That's
-36, but
36.
negative is plus 36.
What's
Wait,
2a?
Plus 36.
2a is 2.
So I have -3 plus or minus. What's 9 plus
We're going a little
36?
quickly right now.
What?
I have 4ac. 4 times 1 times
Oh, it's
-9.
4AC, not 4A, 4AC.
4ac. I probably wrote it wrong down when you
No,
copied
I
it.
wrote it wrong.
No, I wrote it wrong.
Oh, okay.
Don't doubt yourself.
Then I need to.
What's this? What's 9 plus 36?
That
Oh.
is 40.
45.
Do you have an
Wee
eraser?
wee.
It's
5. Don't get impaled. Here comes a pencil.
What if I want to be impaled, just so I don't have to suffer in this
Oh,
world?
this one's so sharp. What?
Real.
Thank you.
This world
It's
is
like
impressive.
perfect. I'm sorry to do that, Patrick.
Is 45 in its simplest form?
No.
So.
What are the factors of 45?
9
9
times
and
5.
9 times 5, so it's 3 square root.
Yeah.
5.
Where did I mess
3
up?
squared root 5. The icon.
Okay, where did I go wrong?
All over 2.
So how many solutions do I have for x?
2. Those.
I have 2.
Yes.
Have you heard of a discriminant?
I
I've
was
heard-
tweaking out over it yesterday during my
It's
math
the
marathon.
b minus cx.
No.
No, it's not that.
It was
No,
like
it's super
something
easy.
weird.
It's super easy.
What is?
I used the discriminant, and suddenly I don't remember it.
Oh, the discriminant.
What's the discriminant?
B squared minus 4ac.
Yes, so what is that? What is this?
If it's positive, then
Well,
answer
okay,
has
wait,
two
wait, let's say-
solutions.
Let's say discriminant is b squared minus 4ac. If b squared minus 4ac is positive,
It has two solutions.
2 solutions.
If it
why
doesn't,
two solutions?
Because it's like a real, kind of like a real answer. I'm not sure.
No, why?
because then you can add a number and subtract.
You're gonna
a number.
you're gonna add a number and subtract a number. If b squared minus 4ac is positive, you're going to get two answers because you're going to be adding and subtracting this
If
component.
it's negative, you're gonna get one answer.
So if it's, let's do 0 next. So b squared minus 4ac is 0. If it's 0, I'm going to be adding
Oh,
and
that's
subtracting
fine.
0. So how many solutions am I going to get?
0.
One.
No.
D&E.
One,
Everything.
1,
1.
1. Because if you add and
Look.
subtract 0, you get the same thing.
Look. Do you accept that you get two solutions here? 3 plus something
Mm-hmm.
over 2, 3 minus something over 2, two different solutions. What if this part had been 0?
Then there would not be the plus and minus, there would be 1.
It would just be minus 3 over 2.
Okay.
So it would just be one solution. So if this part here, under the square root, is 0, then how many solutions do I have?
Solution uno.
1.
Solution uno. I
If
have
it's
uno
negative-
soluciones.
Yeah.
If it's negative, there's no solutions, right?
So that's one real solution. And if b squared minus 4ac is negative, then it's how many real solutions?
Nope.
Not any.
So what is let's see what I just want to look at like the world's most simple quadratic. What's the world's simplest quadratic?
X squared plus
Don't need anything.
Just x squared.
X squared counts. What does that graph look like?
It's a curvy curve.
It's
It's a-
exponential curve.
It's a
Exponential.
curve. It's a curvy curve.
It goes wee. Yes.
So I'm going to try to make this symmetrical. Let's do 3 here. Let's do 3 here.
Or is it?
And let's do 0 here.
To be or not to be?
Um,
Is in fact.
I can
The point doesn't go to the
make
to
this
the 9.
can make this
So it's
happen.
like not vibing with this.
It's not vibing.
So if I try this, maybe it does
Yeah, that's
1, 2,
Yeah.
2,
Yeah,
4,
that's accurate.
3, 9.
Whoa.
Okay.
Whoa there, partner.
Um,
0, 0.
and 0, 0, right? 1 goes to 1, 2 goes to 4, 3 goes to 9.
Wait, I have a question.
Yeah.
I was trying to solve the other one with the quadratic equation on my own. When it gets to -3 plus minus root 9 minus 36, can't you not subtract?
Root
that?
9 minus 36. It's b squared minus 4 times a times c.
Oh, it's -9?
Yeah.
Oh, I miswrote the equation.
c's negative 9.
Okay, thank you.
How many real solutions does this have?
One.
What's a here for this?
One.
1.
1. What's b?
0.
0.
0. What's c?
0.
0.
Oops, c is 0.
there's
So
only one
negative b plus or minus square root of b squared minus 4ac all over 2a. What's negative b?
0.
What's b squared?
0.
What is minus 4ac?
1.
Wait, there's
4.
two
4.
solutions.
Minus 4.
Minus 4 times what's a?
1.
What's c?
0.
0.
Oh wait, it is.
So there's no solution.
Yeah. There's
All
one
over-
solution.
All over what's 2a?
2.
It's 2. So I have
Its
minus
solution
b.
is 0.
I have minus 0 plus or minus square root of 0 over 2 is
0.
0. So where? So what does it mean, Cormac?
Yeah,
I need you to follow what we're doing.
okay, sorry.
What is the meaning of a solution to a quadratic? What's the graphical interpretation, Finn?
The x coordinate where it intersects the x axis.
X-axis. So this, remember, we're solving for x here. So this has a solution when x equals 0. Where is this graph when x equals 0?
The origin.
It's at the origin.
Whoa
So
there.
the fact that I had a discriminant here, I had one solution. So if I have a graph that has one solution, how many times does it touch the x-axis?
Once.
Once.
Once. So if I have let me copy this over. So I can move this around. I can do transform of this graph.
So what it means, like, if the solution is just 1, it would be like the line will touch the axis 1 times, and if there's 2 solutions, it will touch 2 times.
Yes, and then what happens if there's no solutions?
It won't touch.
So what does that look like?
Yeah.
So this would be a different graph. I could move it down, I could move it over. How many times does this cross the x-axis?
2 twice. So
Yeah.
there's 2 solutions.
So there's 2 solutions. And
Would
let me copy
not
this
touching
again.
it at all. Would it be like a circle?
It's the same graph. I'm just transforming it. So so this one, how many times is this? All these different options that I'm moving through right now, how many times is it across the x-axis?
Does.
And then what if I come up here?
One.
And what if I come up here?
0.
0. So any graph that looks like this, that has how many real solutions does it have? It has 0. This has 1. This has 2. So that's what the discriminant does for you, is it tells you if you have 2 solutions, 1 solution, or no solutions.
Gotcha.